In this lecture, we will learn the cross product of two vectors. Suppose you have two non-zero vectors u and v, then the cross product of u and v is defined as u cross v equals to modulus of u times modulus of v sine theta times n, where theta is the angle between u and v and n is the unit vector which is perpendicular to both u and v. You can think in three dimensions. If u goes along the x-axis and v goes along the y-axis, then n will goes along the z-axis, because z-axis is perpendicular to the xy plane. That means perpendicular to both u and v. Now u and v can be anywhere on the xy plane. Now n can goes either upward or downward. Now to determine its direction, we can use the right hand rule. So take your right hand and point out your fingers from u to v like this way. So if you point out this way, then the direction of your thumb would be upward. So the direction of u cross v would be upward. Now if you point your fingers from v to u like this way, then the direction of your thumb would be downward. So the direction of v cross u is downward. This is called a cross product because there is a cross sign between u and v. This is also called a vector product because on the right side we are getting a vector quantity. This n is a vector quantity. Now if you take the modulus sign on both sides, then modulus of n is 1, so we will get this quantity. Now to proceed further, we need to know the determinants. If you have 2 by 2 matrix, the determinant of A, B, C, D is AD minus BC. Now for example, if you have 2 by 2 matrix 1, 2, negative 1, 3, then its determinant is 1 times 3 minus negative 1 times 2, which is 5. Now if you have two vectors u and v, then the cross product also defined using the determinant sign, and it is defined in this way. Now to evaluate its value, first consider I and ignore this column and this row. So the remaining component is u2 u3 v2 v3, and now consider j and ignore this column and this row. So the remaining component is u1 u3 v1 v3, u1 u3 v1 v3, and finally consider k and ignore this column and this row. So the remaining component is u1 u2 v1 v2, u1 u2 v1 v2, and the sign will alter like plus minus plus minus plus minus this way. Now if you simplify this, you will get this result. Now for example, we have two vectors u and v, then u cross v would be ijk. First write the unit vector ijk, then write the components of u and then components of v, and follow this way, and you will get this result. This is a vector quantity, and we learned that u dot v, that means the dot product, is a scalar quantity, whereas the cross product is a vector quantity. Now if you determine v cross u, you will get this result. Did you see v cross u is opposite of u cross v? That means if u cross v goes upward, then v cross u goes downward. Okay? And u cross u, its value is 0. Now if you apply this formula, then u cross u would be also 0, because the angle between u and u is 0 and sine 0 is 0. Now few more properties for cross product. So if you have three vectors u, v and w in R3 and C is a scalar, then u cross v equals to negative v cross u. And u cross u is 0, which you already learned here. This is true for all vectors u. We have two more properties here. Now we need to check few more things, like in dot product we learned that if we take dot product of two vectors u and v, then it is a scalar quantity. And if we take cross product of two vectors u and v, then this is a vector quantity. Now the question is this meaningful? Now v cross w is vector, okay, because we are taking cross product, so this is vector and u also vector. So we can take dot product of this vector and that vector. So this is meaningful. And in second one, v dot w is scalar, because in dot product we got a scalar. So this is scalar, but this is vector. And there's a cross product between them, but we can take cross product only between two vectors. But here we have one vector, but another one is scalar. So we cannot take cross product between a vector and a scalar. So this is meaningless. Next one, so v cross w is vector quantity, u also a vector, and we can take cross product between two vectors. So this is meaningful. In this one, v dot w is scalar and u is a vector, but to take dot product both have to be vector. So this is vector, but this one is scalar, so we cannot take the vector, we cannot take the cross product. So this is meaningless. Now u dot v is scalar, w dot z also scalar, and there is a cross product between them, but cross product only defined between two vectors. But here we have two scalars, so this is meaningless. And finally, u cross v is vector, w cross z also will be vector, so we can take dot product between two vectors, okay, and this is meaningful. Now in this theorem it says that for all vectors u and v in R3, u cross v is orthogonal to both u and v. We already discussed that u cross v is perpendicular or orthogonal to both u and v. Now in this example we have given u and v. We need to find two unit vectors that are perpendicular to both u and v. So we know that the cross product is perpendicular to both u and v, but here they ask the unit vector. So what we can do, we can divide the cross product u cross v by its modulus, then we will get the unit vector which is orthogonal to both u and v. So if u cross v goes upward, then v cross u goes downward. Okay, so first find u cross v, which is 1 negative 1 negative 1, and v cross u would be opposite of this one. So if you multiply by negative 1 here, you will get this result. Now find their modulus, you will get square root of 3, and now divide u cross v, this result, by its modulus, then you will get the desired unit vector. In this theorem, it says that if theta is the smallest angle between two non-zero vectors u and v, then sin theta is modulus of u cross v over modulus of u times modulus of v. From our definition, we learned this one, and if you divide both sides by modulus of u times modulus of v, then sin theta would be this result. Okay. Now, two non-zero vectors u and v are parallel if and only if this reads if and only if u cross v equals to 0. So if they are parallel, then the angle between them is either 0 degree or 180 degree. And sine 0 is 0. Also sine 180 degree is 0. So this result will be always 0. That means this is true. Now, if you have two non-zero vectors and the vectors u and v are adjacent side of a parallelogram, suppose this is u and this is v, modulus of v, then the area of this parallelogram would be modulus of u times modulus of v sine theta. Now question is how? It would be area of this parallelogram. So if this side is modulus of u and that side is modulus of v, then the height of this parallelogram, suppose it is x, and consider this right angle triangle and this angle is theta. So this is opposite. So opposite over hypotenuse, x over modulus of v is sine theta. So x is modulus of v sine theta. So this height is modulus of v sine theta. So the area of this triangle is 1/2 times base times height, and base is modulus of u and height is modulus of v sine theta. So this is area of this triangle, and area of the parallelogram is twice of the area of the triangle. So if you multiply this by 2, you will get area of the parallelogram as modulus of u times modulus of v sine theta, and this is same as modulus of u cross v. Now in this example we have three vertices of a triangle. So this is P, this is Q, and this is R. We need to find area of this triangle. Okay. So first define this vector PQ as u. So u would be q minus p. So 4 minus 0 is 4, 2 minus 0 is 2, 0 minus minus 3 is 3. So u is 4, 2, 3. Similarly, PR equals to V would be 3 minus 0 is 3, 3 minus 0 is 3, 1 minus minus 3 is 4. So V is 3, 3, 4. Now u cross v would be -1, -7, 6, and if you take it modulus, so modulus of u cross v would be square root of -1 square plus -7 square plus 6 square, which is square root of 86, and this one is area of this parallelogram. And we need to find area of the triangle, and area of the triangle would be half of the area of the parallelogram. So if you divide this by 2, you will get area of the triangle. That's it for today's lecture. We will discuss more in next class. Thanks.